Page 3 of Exponentials for Math Studies. For each function, write down the coordinates of the point where the curve cuts the y-axis, in other words, the y-intercept, the equation of the horizontal asymptote. So that means something that looks like y equals a number. Hence, sketch the graph of the function. Let's do this one first. And of course, we are going to, since they gave us a function, first thing we're going to do is we are going to type it into the calculator. So 4 parentheses 2 exponent to the negative x, right arrow, plus 2. Now, if we just want to see what it looks like, we graph it. But if we want to graph it on our grid paper, then normally what we're going to do is we're going to look at the table. So there's a very nice graph, but to draw it exactly on this grid paper, we're going to look at the table instead, second table. And then we'll look, let's see. So looks like we could graph some of these points, the negative x points too. So like negative 1 comma 10 is a point that we could graph. Negative 1, 10, 0, 6, 1, 4, 2, 3. And then after that, it looks like it gets kind of like, gets to be decimal points, right? So like 3, 2.5. And if you keep going, you're probably going to see that it gets, with the y value, gets closer and closer to 2, right? So that means that the 2 is the asymptote. So I'm going to put that the asymptote, which is the part B for number 1, is y equals 2. Coincidentally, not so coincidentally, there's a 2 there. That's actually what causes the asymptote to be 2. And as far as the coordinates where the curve cuts the y-axis, you can look at the graph. The y-axis is here. So the coordinates of the point where it cuts the y-axis would be the x value has to be 0, right? So x is 0, and what is y when x is 0? Well, let's look at the table again. When x equals 0, y equals 6, okay? So for part A, the y-intercept is 6. Now let's do our graph. We're supposed to sketch the graph. Do you see how all these points are positive? So I'm going to, well, I'm talking about the y coordinates. Oops, I can do a better job of that. Ooh, that's really straight, isn't it? Okay, so negative 1 comma 10, 0 comma 6, 1 comma 4, 2 comma 3, and 3 comma 2.5. And then our asymptote, which you're going to draw with the dotted line, is y equals 2. Okay. I drew it with a green line, but you're going to draw it with a dotted line normally. Okay, there you go. Now for the next one. The next one says negative 4. I'm going to go back to y equals again. Negative 4 to the negative x plus 1. So what are you going to guess the asymptote is? That's right, it's going to be 1. It's going to look a little bit different this time, though. Do you see how it starts from the bottom? So when you have negative 4 to the negative x, this negative here makes it start from the bottom. Okay, so if we want to do this graph here, it's nice if we have an xy table so that we know what points to graph. So here's our xy table. Okay, so for example, negative 1 comma, -3. Well, 0, comma 0. Wow, it goes through 0, comma 0. 1, comma 0.75. And then you could see that it gets closer and closer to 1, doesn't it? Okay, so again, our horizontal asymptote, which is part B, is y equals 1. The y-intercept appears to be 0. Okay? All right, let's graph. So in this case, it's a little bit different because it looks like our asymptote's going to be at 1. Okay, so we're going to put one of the points at 0, 0. We're going to put one of the points at -1, comma -3. And we're going to put another point at 1, comma 0.75. And we're going to approach the asymptote, which turns out to be y equals 1. We'll draw it in green again. Okay? So that is our graph for number 2. Now let's go to number 3. Once again, we're going to type it in the calculator. -2, 2 parentheses, to the -x power, right arrow, +3. What do you think the horizontal asymptote is going to be? I think it's going to be +3. Yeah, do you see how it's approaching the value y equals 3? So now if we want to draw it on our grid, it's better if we look at the table. Let's go up a little bit. Let's see, these are interesting points. Okay, so let's look at these points here. So -2, comma -5. Do you see how I'm always choosing points that are kind of close to 0, 0 because it's easier to draw. -1, -1, 0, 1, 1, 2. Okay, and remember the asymptote is at y equals 3, right? So the asymptote is y equals 3, and I know that because the 3 here. So -2, comma -5. Okay, now let's draw our point. So -2, comma -5 is here. -1, -1 is here. 0, comma 1 is here. 1, comma 2 is here. And then our asymptote is at y equals 3. Okay, and draw my curve approaching the asymptote. And do you see how the y-intercept is y equals 1? I'll write that down too. The y-intercept is 1. Okay. All right, let's do number 4. So number 4, we're going to put 3 parentheses, 2 parentheses, to the -x minus 2. And then we're going to graph it. This one comes from the top because this is positive here. This one came from the bottom because of the negative here. And so we're just going to look at the table and we're going to write down some of these values that are easy to graph, such as -2, comma 10, -2, comma 10, -1, 4, 0, 1, and 1, -0.5. Now, I think that probably I'm going to graph like these 3 numbers here. What is the asymptote here? The asymptote would be this value here, which is -2. So I'm going to write that down, that the asymptote is -2. You could also find that the asymptote is -2 by seeing that the y values here are approaching -2. Do you see? Okay. All right, so let's draw our axes. Our axes are going to be have a little bit more room. According to the graph, it'll have a little bit more room on top than on the bottom. So I'll put that. And my asymptote is at y equals -2. And then my graph, I'm going to graph some of these points, such as -1, 4, 0, 1, 1, -0.5. And then it approaches the asymptote there. Okay? And the intercept here is 0, 1. So the y-intercept is 1. Again, right? Last time it was 1, 2. Okay, now the last two numbers, last two problems. So again, I'm just going to type it in first. So I'm going to put 0.5 times parentheses 3 to the -x power plus 2. Now I'm going to graph just to see about what it looks like. Okay, so it starts high and goes down because, do you see the negative here? So when you have the negative here, instead of making it exponential growth, it's exponential decay. It comes down. So the 2 here is going to be the asymptote, right? Do you see how it's approaching y equals 2? So I'm going to put that the asymptote is y equals 2. And the y-intercept we can see easier if maybe if we look at the table. And we need to look at the table anyway so that we can get some values to graph. Okay, these are some big numbers here. Okay, so for example, -2, comma 6.5, -1, comma 3.5, 0, comma 2.5, and 1, comma 2.16. Okay, 2.17. Okay, and then obviously we're getting close to an asymptote here because you can see that the y values are approaching 2, right? So our asymptote is y equals 2. So if we look at our graph, we can kind of see how where we should put our axes. It's mostly on top of the axes. So I'll just make an axis here, make an axis here, and then I'll start graphing some points. So -2, comma, oops, it's kind of off center there. Okay. -2, comma 6.5, -2, 6.5 would be about there. -1, 3.5, that would be about there. 0, comma 2.5, that would be there. 1, comma 2.17 would be out there. We could draw our horizontal asymptote, and then we'll connect our points. That was a terrible drawing. Okay, kind of like that, right? Okay, let's do our last one. So it's 0.5 to the exponent of -x, right arrow, plus 1. Just to get an idea of what it looks like, we'll graph it like this. Interesting. Since there's a negative here, we think, oh, okay, so I'm going to see exponential decay. But do you see how they put the base of 0.5? When they put the base of 0.5, that also would make you think it's the opposite. So 0.5 would mean it's the opposite. -x means it would be the opposite. So they're both opposite, so it ends up being positive. It's kind of hard to explain, but remember that if you have 2 to the -1, that's equal to 1/2. If you have 1/2 to the -1, that is equal to 2. So that's kind of the situation we're in. We have 0.5 to the negative something, so that gives us a number that's bigger than 1. Okay? But you can trust your calculator here. And the asymptote the asymptote is going to be y equals 1. Oh, by the way, the y-intercept here is 2.5, right? There's your y-intercept. Okay, and then, so y equals 1 is the asymptote. And then let's look at the grid, or look at the table to see how we should map our points on the grid. Okay, so we have, for example, negative 1, 1.5, negative, or 0, 2, 1, 3, 2, 5, 3, 9. Okay, and so looking at the graph, looks like we need more space on top than on the bottom. So I'm just going to put my lines there and start graphing my points. Negative 1, 1.5 is about there. 0, 2 is there. 1, 3 is here. 2, 5 is here. And 3, 9 is here. And where is our horizontal asymptote? It's there, positive 1. So it's y equals 1, right? We already knew that. And what is our y-intercept? It's 2, right? 0, 2, so it's 2. The y-intercept is 2. Okay, so that is it for page 3.